Hello everyone and welcome to Try Rights, the new era of learning. My name is Sheikh Abdul Rafiq and I will be your data science trainer. And today's section or topic is data science linear function. Let's move into the topic. Linear function has one independent variable x and one dependent variable y, right? In this, linear function play a crucial role in data science. Yes, especially in predictive modeling and statistical analysis. A linear function is a mathematical function that describes a straight line relationship between an independent variable x and a dependent variable y, typically expressed as y equal to ax plus b. It expressed like a graph pattern which is move xy, it moves forward from the x to the y, a straight line linear. Okay, we use formula equation lab is x equal to ax plus b. Okay, so defining the formula, y is nothing but it is the output of the equation. Okay, and x is nothing but input of independent variable which we are giving. Okay, and a is the slope indicating the rate of change of y whenever the behavior of dependent variable changes, and instant the behavior of x value also changes with respect of x. See, it is a coefficient of the independent value. Okay, and b is the intercept represented the value of x represent value of y, right? When x equal to 0, it starts with both are starts with constant direction, a fixed variable. It intercept nothing but a fixed variable. It starts with a constant number. Okay, right. What are the applications of data science? Right, applications of data science is nothing but regression analysis and future scaling and optimization and data visualization. Right, regression scaling is nothing but linear function linear function regress the models using linear functions to predict our outcomes based on input variables. Right, so see that linear regression models, the basic models used to linear functions, which is used in data science to predict our outcomes based on input variables. Okay. Future scaling is nothing but normalizing the techniques often rely on linear transformation and optimization. Many machines learning algorithms optimize linear function to find the best parameters. Okay, you all also know about the data visualization from the beginning of the section. Linear trends help in understanding patterns in data science. Okay, now let's take an example. Okay, so by using the equation of this, we take a concept and we instead of that we using the equation we find the calculation of what the required. Okay, so my requirement is the sport watch data set, right? So here we are watching here duration, average pulse, max pulse, calories burnage, hours of work, hours sleep, right? Here a prediction, a data set. The data set is above consist of 6 variables, each with a 10 observation, right? We have 10 data sets. See, a function with one explanatory variable means that we use one variable for prediction. Let us say we want to predict calories burnage using average pulse. We have the following formula. So the requirement is we want to calculate the average pulse according to the calories burnage. If the graph in the graph we have 80 average pulse, so according to the how much calories does it burns, we have to show the slope, right? This is our prediction. We want to predict the data by instanting taking the average pulse and taking connect with the two calories burnage, right? We show a visualization in a graph pattern. So okay, is the requirement. We can use the formula C. We can use the one variable for prediction y equal to x only, as we know it is a equation formula. Let take consider into f of x equal to 2x plus 80, right? Where f of x, where in that instant of displace we have y and here Instant from that, we take f of x, the output, input which is the average. X is nothing but we taking as the input which we are giving. So x we consider as x equal to average pulse, right? 2. 2 is the slope. Specifically, how much calories burnage increased if the average pulse increased by 1. Slope is nothing but whenever we predict in the data in the graph pattern how much the constant is increasing to forward. It calculates the slope according to the direction to target to the y-axis, right? 80 is intercept, a fixed value. Whenever the concept of slope and intercept, then I define the clarity of this whole equation. For that, now keep this side and take the equation, and we move into the this data set. See, I have arranged the data set in my Excel. Okay, has this requirement. So I take this requirement into the VS Code, and after that, I have to perform the a calories burnage by showing the graph visualization. Okay, let's let's move the in this concept. We also introduce a matplotlib. Okay, matplotlib in also explained in this concept. Okay, open the VS Code. Yesterday we have created a data table like this, right? Instead of this, we directly read the file and import in code. Okay, now take a file, put the function as ds linear function. Okay, now we have, okay, wait, sorry for that. I didn't mention ds linear linear function dot py. Okay, right? Now we have to import that file. Open the graph. Here I have a health data, right? This is my data. Drag and import in VS Code. Import it. Let's see. Data stands here. See, my data is duration, average plus all the recording data is arranged in one place. And now I have to perform a using this. I have to import in my code, right? Now, now take the import matplotlib. First of all, I want to tell about matplotlib a little bit. Okay, Mm, matplotlib is nothing but it is a calculation based. It is it is a visualization in graph, right? It used to show the data in the. It is matplotlib is nothing but it is used for visualization part to represent the data in a structured manner. Okay, how we install matplotlib? Install pip, right? Pip install matplotlib, same as numpy and pandas. Install matplotlib. Okay, now import it. Import matplotlib and I want to take another one. So py dot plot. I want to take this function. Plot is importing. Plot is nothing but, for example, I can show like that. Wait, it's a x and y axis like that. X representing the data in x and y. So we use the plot as x is this variable, so x is to this, y is to this x, y axis to one way, one list, and x equal to one list. You can say any data y x equal to one data, y equal to one data, which represents the y axis, and x axis is nothing but a plot. Import plot has plt, and yesterday we discussed about pandas now. Import pandas. as PD. Now, yesterday we created data like this, right? Where is pandas file? No pandas file. And okay, we created data. Yeah, we created data like this, right? So instead of this part, we create we directly import from this data into the linear function by using pandas. How we do? PD dot. We have a function called read CSV, and I give x equal to x read CSV from where you want to read the data. What is my file name? Health data, right? Health data, health data dot CSV. Highlight it. Okay, now right. Now I want to give the a little another function like another function we have headers and separate them with by column. In a huge data we use this too, but in little bit data we don't that much not required. Okay, now uh, put in this one variable. I take a variable like health data, right? And now print the health data. Now see the graph will show properly. We can see we can see in table manner. The output is become we can see a proper structured table. See, we have same has like this now. See data, same duration, average pulse. See in Excel how it arrange. See data has same as arranged in VS Code, right? Okay, now we want to instead we are doing prediction with average pulse and calories burnage. For uh, take a direction, how much if the 80 to instant of slope to directly connect with 240, right? I'll show in graph. Wait, what button? Now take the health data and I show no plot is nothing but we are assigning the values for x and y axis. So here my x and y axis is x equal to x equal to my average pulse, right? Data is right. When you are assigning the data to the code, you didn't make any mistake in spellings. Okay, you didn't read the value, right? Now y equal to take calories burnage, take calories burnage, and I want to stride kind is also a integer function to measure what is linear is nothing but a straight line. No? Take a function as line, right? Finish. Our graph train is ready. Now we want to uh, see here we import pandas and we make a table by using panda by reading the Excel sheet, and after that matplotlib we didn't use a plot py plot we use as a giving the assigning the values x is average pulse and y is calories burnage, and now remaining we has plot plt, right? Of now come we have to give the main axis for plt, assign it for plt dot ylim. It is for y axis y me Do we start the values from min equal to 0 and y max from take estimation what is the highest value of okay, 330. So I take 400. Now PLT for xlim. Now x min. I want to store 0 from 0. From x max, I want to start from what is the highest value 120. So I take 150 constant. So it is nothing but x mean and max functions. You all know it is I whenever my graph starts, it starts with 0, not in between the value of 10, 25. I want to start at my graph y-axis and y-axis. At the starting point is I'm giving 0 as min, and in the end point I have given max as 150, right? And we want to show the graph. We have a function called plt show. It will visualize the graph. Now run the data. See, the data is done, right? See here. I'm saving for it. See, we are accessing 80. Where we average pulse from where the average pulse is starting. See, from 80, its average pulse is starting, right? 80. See in the graph, the average pulse is starting from 80, right? Where the average calories burnage triggers to 80, 240, right? 240 up to 330. This is 80 to triggering 240. Okay, let us wait. I explain in a little bit more for you for easy understanding about this. Right, we have data like that. Now we want to assign the value like this. So if we find for a text right, let's better, right? Instead of drawing, we take a straight line is better. See here the data. So 200 here we have the 240 line, right? Right, see, we are arranging the data. It's directly triggering to there, and wait, see, it is into the 240, right? It is nothing but the slope variable we are watching here. Slope, where it is a slope of the variable. It connecting its edge, right? So this is the function we are showing. We have to assign a value for it. Average pulse is starting from 80 and it triggering for 250. Okay. If you want to change the data, like I want to predict the data from 10, not from straightly going to the 80, right? At that case, I have already a data has data. Instead of I already created that. Or in case we can also create a data like that. Right? Where is my uh, yeah, here already I created for you. See, instead of this, we're taking directly inputting. We see it here also. You want to understand about that average per Scarlett Berners. I take min value according to the 10, 20, and here from 40 to 330. So I assign the values, and here didn't give in math, so it is not a big problem. I think it's maybe take 330 minutes to average value take around 400 or 350. Right. See the this there. See here. Now you taking a zigzag value. See I given. See how it's going. If the data is 10 instead of value, if the average pulse is 10, it's triggering to the 40 calories burnage. If the average is 20, it's triggering to the direct 50. See here 50. Okay, you understand? And now see the 125. Here the 125 measures to exactly here, I think. So I will trigger the data 125, then triggering to the 330, right? 330 here, right? And this, how this, like this, we can predict the data. Okay, I said you to explain about this. Wait 1 second. And in the beginning of the class, I explained the equation how 2 and 80 will comes in the picture. In detail, I explained about it. Moving forward, I want to tell what is slope and what is intercept. So your guys all understand what is slope. Slope is nothing but a value is triggering. Like it is a coefficient of independent values. Each slope shows how much the dependent variable changes. Okay, with our 1 unit increases or you has according to your range how much it increasing. It depends on it the changes. Independent variable keeps the other ways constant. Okay, for example, if the slope for 1 year experience is 2 year, then so each additional adds 2000 lakhs in salary. Like wait, I explained in this graph only. I didn't take any other graph to explain you. But I take another line has green straight line. Let us assume 80 here as V80 as starting point of X is 80. Let us assume we're targeting a data in between 18 and 119, right? See here 18 and 19. Directly we target triggered here, right? See here we triggered from up to there. And instead of this 90, it will directly, I think it triggers to 240. 90 it triggers to, so 80 triggers to 240. And so the data will, I think 90 will definitely trigger for 260. As 260 it will trigger to 260 correctly. I found correctly right. It triggers to 260. Yeah, because it increasing by 20 now. If the point was wait a second. See here, here we have increasing the data like see it is increasing by 80, right? It directly a slope intercept with and directly connected to 240. It is the y, where is the y axis and it is x axis, right? See the data is interconnecting with 240. Here the data is 240, and here the data is 260, right? It is directly interlinking with 90. Okay. For now, according to the calculations, we have to take the data as variable, right? I said this is the intercept of slope, and I explained about the intercept too. Intercept is nothing but the value of dependent variable when all the independent variable are zero, right? It represents the straight point. It represents the straight point of the line to y-axis, equal to the straight point to the y onwards to the y-axis. Whenever you're triggering a data to slope, it directly triggers the y-axis, right? This intercept. Okay, now take the variable. I take other color, green. Okay, on I take. Okay, now this is I take the this is second observation, first observation. This is second observation, and we take data as x1 18. I think I take this as x1. Okay, in x-axis I take this x1, and I consider the 90 as x2 because both are x-axis in the line of x-axis. No, so okay, okay, 240 I consider as y1. Okay, and 260 I consider as y2. Okay, now see it is the first observation of the x-axis. Okay, x1 is nothing but is the first observation of the average pulse 80. Second observation of the average pulse is x2 90, right? X2 90. And same like in y-axis the first observation is 240. in calories burned, and second observation of the calories burned is 260 has y2. Okay, so this data we want to calculate. Now we predicted. Now we want to predict how the 2 and 80 will occur. Okay, now for this I take another variable like weight, which okay, here slope dot py. I take the data here. Okay, for this, wait, sorry. Okay, what is our data f of x now? Equal to 2x plus 80, right? For the equation, see here the average pulse were increased by 10 or 20 in the range. See, we can consider here in the graph, we can see it increasing by the range of 10 or 20, right? Okay, let us we assume if the let we assume has I'm trying to explain clearly, guys. As we see the average, let us take a requirement as we seeing the average AV average pulse increase it by 10. Increase it with 10, like with 10, increase it with 10. It is the first iteration, and second as we see, oh, let us just remove it. Only has like okay. Now the calories burnage. Okay, the calories burnage increased with 20, right? This is the equation 20. Now, now we have a formula like y by x, like in equation y by x. So y by x is means so directly connects to y by x. So we have considered 20 by 10. It's nothing but data is 2, right? 2 equals to 2. So the slope is 2, right? 2 equal to 2 is nothing but is a slope. Slope is 2. Okay, right. In this case, we just calculated by our mind, right? We don't do any calculation, but machine did not understand and did a human calculation by directly assuming in our mind and directly we write on the like code like this. So we want to tell the machine, I want the calculation equation for this. So I if we assumed we the value is two. So let the machine also assume the value is two. So for that we have to take a equation of a method, a code like use slope on like slope, take the variables x1 comma y1 y1 comma x2 comma y2, right? We have the equation like that, and further we want to take another equation like formula we have. Okay, for this I take a form we consider in slope formula. What is the slope formula? F of x, right? F of x2 minus firstly we take y, now y axis is first, now y2 minus y1, right? Y2 minus f of y1, and by f of x2 minus f of x1. Okay, this is our slope formula. Instead of this, we take y2 minus y1 by x2 minus x2. So I just put you understand easily like that f of x. So take the con and common the f in the common the f equal to I take y2 minus y2 minus y1, and by x2 minus x1. right? X2 minus X1. This is uh, now return F and give return F, and after that give the assign the values for the given inputs. Print slope for X1 what the data is we will for X1 what is the data? For X1 data is 80, for X2 90, 240, 260 for Y2, right? But assign those values to the correct X1 for 80, comma 240, comma 90, comma 260, right? Now see if the machine also understanding the give the output has true or not. I think I want to close it. Okay, okay. Now see the output. See here we mentioned two, right? Instead of we get float value because in this graph linear we get in float values because we did not represent one value because see I will explain clearly for you. Here we see the values are constantly repeating by the divided by 2, right? 280 also divided by 2, 240 also divided by 2, or 2 and 10, 90 also divided by 2, 2 and 10, and 260. All divided divisible values, right? In this case, I give a one non-divisible with value. Okay, see the data now. Here 97 is not divided by 2 or 10, right? Now see why we take float with output. It, see, it gives a 1.7647, right? So for the constant data, we take as like that. It represents as 2.0. Okay, you're clear about it? No, I take the intercept value to intercept and I find slope for you, right? No, right. Okay, done. Now I have to print the data like assumption. My assumption is nothing but I have to show the data like taking a prediction. Now we take a prediction, right? Instead of talking like this directly slope intersect and intercept weight y-axis. For that we take an example, right? Now my requirement is in case I take the data has now I have highest data is 130 now. Instead of this, I take a data like this. Okay, hello. Instead of this, I take data as 140. Let's we take 140, and I have just predicting the value, right? I see where the 140 is triggering. 140 is triggering for 160 like or 150, 350 around the 350 it will trigger. Okay, around 350 or 360. I mean, it increased by 360 now. It triggers with 360. The variables are y-axis is increasing by uh, 20 now. So if you trigger 20 in between the distance 240 is 20, 260 to 350 is trigger means or the data between in range of 340 to 360 to yeah it definitely triggers the 360. It is my assumption. Okay. I predicted data. I triggered it for 440. It is my assumption. I trigger the data has 240. I trigger the data has 240 here and it directly triggers the intersect with slope and it intercepts the direction for the y-axis directly intercepting with y-axis, right? Now it is my prediction. I give a input x has a 140 and it triggers slope and it intercepts with y-axis on the 360. It is just my assumption, prediction. Like we have to predict the data. Now for this prediction, now I have to confirm the prediction. So let us write a code for it to confirming the prediction of in this case, I also introduced one new function for you. It is useful and helpful for us. Okay, now we can put data like that. Import matplotlib, import matplotlib No, I said no py plot for arranging using the assigning the value for x-axis and y-axis, and pl take a value as alias plt import pandas for data table and assign as pd for it. And we already take the data, right? Pd dot read cv. What is my data? Health data. Okay, dot csv, right? For the given data, I have to consider headers 0, the 0, and separate with 0. So sorry, separate with comma. Okay. Now put the data into a variable called health data. Health data equal to take the health data here and assign the plot for it. Which value were we giving assigning for x? I assigning x equal to I'm assigning the average pulse, right? There is the previous data, right? For x value, okay. Instead of that, I copy this line. It is better to okay, right? We have assigned the plot, and now let's take the p same as plt dot ylim. Y mean I'm starts from 0. Y max has start for 400 because I'm taking long. My assumption is 360, no? So it in between the 400 to 300. So I take max value as 400, right? Y lim for it. Okay, y min equal to 0, right? And x max equal to 200. I take the data because I take a prediction for it. First, I have to print the data to show you which is triggering. Okay, right? This is our data. Okay. Now for this data, I have to consider I have to change little bit change. This is our actual data, right? So in that case, I have to change something. Okay. Now wait. I want to take matplotlib, but matplotlib doesn't calculate in this equation. I want to predict data, right? Okay, man. First, I have to predict data with Python, not with NumPy, not with pandas, with NumPy. So here get little confused about it. Not take because I take matplotlib, so I want to take here NumPy for calculation. We use NumPy now. That's why I removing this. Okay, now take the data like I have my assumption is 140. I said no, I take the 140 here. My assumption is 140, and it hitting the 360. So I have to prove where the data is hitting. Uh, Assumption where prediction value is what the prediction value is 360, right? Now come to the function. I have to first prove the function. Which function we have? What the equation f of x equal to 2x plus 80, right? First, I have to show this equation you. Right, this is our equation. To right, let's take the equation into the code. Def prediction. I have to predict data. I'm assigning a value prediction for x value. I'm doing 140. I am returning the equation 2 into x plus 80. Right now, print the prediction value. Print the prediction, and I am assigning here 140 x value as input. Now see how much the data will trigger. Let my assumption is correct or not. See, my assumption is correct. 360, triggering 360. Okay, done. All right. For this, I write the code again. Import matplotlib. Right? You have clarity. Already. Okay. Now you get clarity about it. See, my prediction data is 140, and its slope intersect and with y-axis where 360. And see, here also I intersect. I give a value as 140, and I get 360. Right? Like this, we have to identify the slope concept. For the another concept, I had into why the 80, I didn't explain no in the equation why we count 80. Let be, we are also explain about that too. Get instead of this, I take a clean graph. It is better to us to understand better. Okay, now I taking a clean graph again. Why the point is 80? Right. So it is the value of starting average pulse. So it is my starting point, right? It is directly correct, and it is my predicted value 240, right? 240. Yeah, actually it is right. This the data is considered, right? For this straight line triggering to 80 here, 80. See that the straight line triggering to 80. See, so that's why the in formula we have take B have intercept a fixed value, right? As I said, at fixed value 80. Whenever the slope intersect with the y-axis, the straight line which you are assigning in the graph is directly connected to the range of the y-axis. So here 80. So in equation we take as 80, right? I think you understand this concept about the linear function. And thank you guys.